Whenever you're ready, we can start.
Okay.
Good whenever.
Okay.
Open it up here and make sure I got it going on. All right, let's go.
Okay. So number 2 says, which of the following variables S are quantitative? Mark all that apply. The number of people in a randomly selected classroom on campus, the 3 most common brands of car found in the US, and the telephone number of a randomly selected business in town. I would go with the first option.
Yep, I think just A.
Yeah, the number of people.
No.
So that's the number of people in a randomly selected classroom on campus, correct?
Yes.
Correct.
So in the quiz here, it's the third option.
First option on the. Or are you in the actual quiz itself?
Yeah, I'm in the actual quiz, but that's all right.
Well, that's probably a good idea. Then we just have to do this once instead of going over the whole thing twice.
That's smart. Smart move. Let me pull up the quiz.
Yeah, just a moment.
Okay, true. So then it's the third one. Yeah, the amount of number. Let me download the Excel files we will be using. Rates of return flights. Okay. Okay.
True. And then, yeah, so the third option, number of people in a randomly selected classroom.
Okay, who wants to rate number 3?
I will go. A student in an introductory statistics class at BYU, Idaho, were studying prices of cold cereal at a grocery store in Rexburg. To get a sample of cold cereal prices, they went to Albertsons and rolled a die to decide which box from the left of the top shelf they would start on. They then recorded every 6th cereal after the first, moving from left to right down the shelves, recording the name, size, and price of each cereal in their sample. Is this study an experiment or an observational study, and why? So I put that it was an experiment because they had a control over the what was it? Control over the cereal that they would use for the sampling method.
I was thinking as the third option, an experiment, because the students had control over which sampling method they used.
Yeah, that's.
So I was thinking that it's an observational study because they have no control over the price and they're observing the price. But I'm torn between that and the experiment, the third one.
Because even though they have no control over a cereal, they have control over what experiment they are choosing to go with.
Right, and I need to do a review on this, but okay.
I think more of an observational study would be like maybe if they were standing at a check stand and they were, as people brought the cereal to it, that they just took whatever cereals that people brought to it. That would be more of an observational study, I think.
Yeah,
I can agree with that. Okay. So it's the
third option.
Yeah. The next question, it says, for Math 221 project, one group of students studied the ages of students on the BYU Idaho campus. Sample of n equals 100. Sample mean was 21.2 and the sample standard deviation was 2.61. Shows an excerpt of their data, and the group notices that there's an error. The age of one of the males was entered incorrectly. He's actually 21 years old. When the error is corrected, what will happen to the sample median? I put that the sample median will increase.
That's what I
Yes.
put also. Yep. So that's the first option.
So then 5 says the time to complete a standardized exam in the BYU Idaho Testing Center is approximately normal with a mean of 70 minutes and a standard deviation of 10 minutes. Using the 60, 95, 97.7 rule, approximately what percentage of students will complete the exam in under 50 minutes? Give your answer accurate to 1 decimal place. I was having 50 minus 70 divided by 10.
You said 50, which is your X bar, correct? Minus
Yes,
70, which is X,
correct.
divided by 10, which is your standard deviation.
That brought us with a score of -2.
All right. If you put that in, that's your z-score is a -2. So if you enter -2,
Yep. And then with the applet, since we have a mean of 70, will be just the left side being shaded. So I come up with a p-value and probability of 0.23. 0.023.
0.023. When I follow that procedure, I get the same answer.
Yeah.
0.23. Okay. So question 6. The score on the LSAT are approximately normal with mean of 150.7 and standard deviation of 10.2. Queen's School of Business in Kingston, Ontario requires a minimum LSAT score of 157 for admission. Find the 35th percentile of the LSAT score. Give your answer accurate to 1 decimal place. So,
This is the same equation, correct?
Yeah, I just put on the applet 35 percentile and I come up with 0.935 as the z-score, and that's equal to x, which is the variable we're looking for, minus 150.7, which is the mean, divided by standard deviation 10.2.
Okay, so
I got
you put
the
35.
z-score. Sorry, I
I'm
just
sorry?
got a z-score of -3.385 when I put that in.
385. Do you have both sides shaded or just one?
Let me pull it back up.
35. Yep, you're right. It's 385, -385.
Yeah, because we just want the one side shaded. Is that right?
It's because it's the 35 percentile.
Yeah.
So it's which side do you shade on this one? Remind me of that because I shaded the right.
The left side, because we're looking for
Right.
35, which is less than 50, which is the mean.
Okay, so I shaded the wrong side, but I was okay. So technically, I was in the what's that make it the 65th percentile?
Yeah.
Okay, so you entered 0.35, got a z-score of -0.385.
Correct. Yeah.
Yeah.
And so once I got that all figured out, I got a final score of the 146.773, which just need 1 decimal point.
Yeah, will be 146.8.
Okay, so hold on a second. So you entered your z-score
Mhm.
Correct.
into the equation, and you're looking for, so it should look like z equals, which one are we trying to figure out here?
X. X minus 150.7
Okay, z equals x minus 150.7.
divided by 10.2. And
Right.
Z is the negative 0.385.
Right. Yep. Okay.
Then you solve for X.
Okay, got that. Okay. All right. Your final equation was on that one?
The final answer, I got 146.8.
Okay. Let me grab my calculator again. Looks good. Excuse me. All right. So the supposed sample size of this study was n equals 2. What would the shape of the distribution sample means look like? Oh, sorry. I needed to read the whole thing. Forgot that those were different questions. When I printed mine out, the breakup is really weird on this one.
Yeah.
Okay, so a team of dermatologists researching study of skin cancer among 60 to 70-year-old American men. Suppose you were a part of the research team and take a sample of n equals 70 men from this age group are calculating the mean number of skin cancer in that sample. Also, suppose that it is known that the distribution of the number of cancer spots is right skewed. Well, so suppose the sample size for this study was n equals 2. What would the shape of the distribution of the sample mean? Well, n equals 2 is awful small.
Yes.
Right. So that's
Small.
making me think that we can't be sure until we examine the data, is what I was thinking.
I was thinking of that one as well. Because the sample of tweets is very small, so we need to take a look at more details so we can verify what kind of graph we can get.
It is also supposed it is known that the distribution of the number of cancer spots is right skewed. So is that going to be on your total population or just on this sample? Because if it's on your total population, then you're still going to have
Right skewed. Because it's also supposed that it is known that the distribution of the number of cancer spots is right skewed. So it's not only for the sample, but
I would say that your sample being 2, even though it's tiny, you're still going to know that it's still going to be right skewed because your parent sample is right skewed.
even though the sample size is too small.
Because it could be that we get 2 samples that are one on one of the sides or just
Okay,
out.
I'll buy that. We can't decide until we know the data.
Yeah, if you want, can go with that one. We can check.
Okay.
The next one says, tanker trucks are designed to carry huge quantities of gasoline from refineries to filling stations. A factory that manufactures the tank of the trucks claim to manufacture tanks with a capacity of 8,550 gallons of gasoline. The actual capacity of the tanks is normally distributed with mean equal to 8544 gallons and a standard deviation equal 12. Suppose that a simple random sample of n equal 20 tanks is selected and the sample mean capacity is found to be 8550. What is the z-score corresponding to the sample mean? Run your answer to 3 decimal places. That's when the equation I use, it's 8550 minus 8544 divided 12, which is divided by the square root of 20.
Hold on a second. Where are you getting 8550? I see. Okay. Online it says 8550, but on my paper it said 8544. So when I looked at my
That's what I was
equation,
thinking too.
And
yep. So I need to rework my equation. So it's 8550, which is the X bar. Z equals X bar minus U divided by standard deviation. So
yeah.
where's that at there?
And then this one is because a sample n it's given, are we not taking as well the standard deviation divided
Yes.
by the
Divided
square
by
root of n,
square root.
right?
Correct.
Right, the square root of it, yep.
So 8550. Oops, 8544.
I came out with 2.236 as the C-score.
That is also what I just came up with.
8550 minus 8544 equals divide by 12 divided by 20 square root equals 2.236.
Yes.
Yep.
So 2.236 to that 2.236. Save. Question 9.
So question 9, what is the probability that the sample mean capacity of 50 randomly selected tanks will be greater than 8540 gallons, around to 3 decimal places? So this time would be the 8540 minus the 8544 divided by 12 over square root of 50, right?
Yes.
So for that one, I ended up getting 0.991.
Now, is that just our Z-score, and then we have to go put it in the probability? Or not?
Yes, the C-score on the probability applet, and the area will be the final answer.
Okay, so what was your Z-score again? Let me finish up here, 8450.
Negative 2.357. And in this one, Carrie, what side of the applet were you shading?
I'm not sure.
Because this one
I'm
says will be greater than 8540. Yeah, which is including the mean as well. So will be, I am thinking the center and the right side.
Okay.
Negative 2.357. Put that in the applet. Sorry, I'm slow coming to the party here. 2.357. Let's know which is going to be greater.
That says greater than
So shade right.
8540. I'm thinking I'm shading the center because the mean it's 8544. So we're starting at 8540 and then the right side as well.
Right.
So will be 0.991.
Right. Yeah, it looks like I didn't have the right side shaded. Or 0.991, is that what we
You
said?
need the center and the right?
Yeah, so center and right.
Center and the right side, yes.
Okay.
0.991.
0.9908 equals probability equals 0.991.
Yes.
Okay. 0.991. Number 10. Which one of the following best describes the notion of the significance level of a hypothesis test? Significance level. Let's see here.
So now the probability of a type 1 error.
I believe that is correct.
The type 1 error.
Yeah, that's what I was having in here. So then question 11 says the heights of young adult females in the United States are said to have a population standard deviation of 2.6 inches. A sample was taken of N equal to 85 young adult females at a BYU, Idaho, and the mean was computed to be equal 65.4 inches. Which of the following explanations describes the correct way to interpret the 95% confidence interval for this problem? I was thinking as on the test, the third option, which is approximately 95% of all 95% confidence intervals that could be computed from the population of all adult females in the United States will contain the true mean height.
And then this one you do more than the one. I was thinking the last one also, that we are 95% confident the true mean height of adult females in the United States is somewhere in our confidence interval.
Yeah, you're right.
So which one is that? I'm sorry, looking on the test.
The last one.
The
Yeah,
third
so
and the last one.
The third one is approximately 95% of all 95%. I agree with that one. And the last one, we are 95% confident that the true mean height of adult females in the United States is somewhere in our confidence interval.
Correct.
Okay.
All right, so question 12. Marine biologists have been studying the effects of acidification of the oceans on weight of male beluga whales in the Arctic Ocean. One of the studies involved a random sample of 16 beluga whales. The researchers want to create a 95% confidence interval to estimate the true mean weight of male beluga whales. Their data follows a normal distribution. Population standard deviation of weights of the male beluga whales is 125 kilograms, and the researchers feel comfortable using the standard deviation for their confidence interval. Are the requirements for use of a confidence interval met? Explain. That would be yes. The distribution of sample means is normal because the data are normal.
I was thinking was the last one. What says no, the distribution of sample mean is not normal because the sample size is small, because we have 16 only.
Yeah, but if your population, oh wait a minute. I guess that doesn't matter, right? Does it?
I was thinking it had to be one or the other, either if your data was normal or if the sample size was large enough, is what I was thinking.
I think it has to be the population has to be normal. It's known, if it's known that the population is normal, I need to go review that one too.
So there are their data follow a normal distribution.
So the distribution of a sample mean is normal when your X bar is normally distributed, or when, thanks to the central limit theorem, our sampling size of N is large. So that's the condition. So if your distribution of your sample mean is normal when your observed is normally distributed. So if it's telling us it's normally distributed, then I'm going to say the sample mean is normally because data are normal. Is that not right?
That sounds right.
That's how I read what come out of the lesson recap from lesson 7. Does that not argue for the first one?
No, kind of makes sense if the population is normally distributed. That's the same as we did with the sample that we had previously as N2. If it is right, it's skewed, something like that. So then would you like to go with the first one, that yes, the distribution of sample mean is normal because the sample size is large, or the second, the distribution of sample
is normal, not the first one, my bad.
Yeah, the second one.
Yeah, the second, sample mean is normal because the data are normal. Okay. At the next one says, an investor with a stock portfolio worth several $100,000 used his brokerage firm because he felt the lack of diversification in his portfolio led to poor performance for many years in a row. In an effort to avoid close public scrutiny, the firm agreed to settle the conflict by an arbitration panel. The arbitration panel compared a sample of 39 months of the investor's return with the average of the Standard & Poor's 500 stock index for the same period in order to determine whether there was a substantial decrease. The data are recorded on the rates of return. The S&P has a known population mean return of 0.95. Suppose that you're a member of this arbitration panel. Conduct a hypothesis test to determine if the investor's portfolio performs significantly worse than the performance of S&P 500. Use a level of significance of 0.05. The value for this.
Sorry. Did I lose you?
Let me pull the Excel file.
So on this, we just got to plug it into the one sample t-test for means, right?
Yeah.
Okay.
So I come up with a p-value of 1.
Step in those. 1 second.
So I can't get my, well, I got to get this to open up here.
Yep, I'm getting as well the p-value of 1.
Open up. Excuse me. One sample t-test. There, it finally opened. Let me just copy that real quick.
Okay.
Sorry about that. And here we go. Copy. Come on, just paste in there. So my t-score is negative 1.152. Is that what we're looking for there? And we're looking for
The p-value.
okay. Oh, there it is. I got 0.87.
Is
What am I
p-value.
doing?
For a p-value?
Yeah.
Are you taking the p-value given on the spreadsheet, or are you typing it on the applet?
On the spreadsheet.
I come out with p-value of 1.
Okay, so let me double check here. Well, I'm looking for less than, not greater than, aren't I? Nope. One sample t-test, correct?
Yes,
Confidence level 95.
correct. Oh, let me. Yeah, you're right. It's because we had in the spreadsheet the null hypothesis as 10. I just erased the null hypothesis, and the p-value is 0.872. Is it what you got?
Are we looking
Okay.
for greater than, or are we looking for less than?
Let me just recheck the instructions. 872. Suppose you remember conducting hypothesis to determine if the investor's portfolio performs significantly worse, so it's lower than.
I need less than,
Less than.
correct?
Yeah, it changed the p-value to 0.128. Is it what you were getting?
Yes. If I copy the data in and I put a confidence level in with a null hypothesis of 0.
Correct. And the type of test being less than 0.128. Yeah.
Um, So is the null hypothesis just 0?
Yes, because we don't have a specification of the null hypothesis on the.
So at the end of where it says the S&P has a known population mean return of 0.95, isn't that what we're comparing it to? The 0.95? Or am I looking at this wrong?
So this B has a known population mean return of 0.95. So as a return
No,
example.
like our,
I know we're
Copy.
trying to get, yeah, it's, you need a null hypothesis, right?
Yes.
yeah.
There's returns with the average of the standards Poor's 500 stock index for the same period in order to determine whether there is a substantial decrease of data recorded then. Should mean return of 0.95. Yeah, that's the other online data we have. The S&P has a known population mean return of 0.95. If we put 0.95 on there, we get a p-value of 0.019.
Mhm. I ended up with doing it that way, putting the 0.95 in there, 0.019.
Yes.
Right, that's what I got also.
Okay.
Thank you.
Point 0.019. Entered and saved.
Alright. Good to go to question 14.
Yeah.
Okay, a financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by their wives. Should he use independent sampling or dependent sampling, and why? He would need to use the dependent sampling, right? Because the wife and husband go together.
Yeah, I think it's the second one. It's
Second
in
option.
couples, for example. So whether a particular wife is included depends on whether her husband is included.
Correct. So this cough that I've had for the last 3.5 weeks, I'm not feeling very confident because my wife got it 2 weeks before I did, and she still is
Really?
Oh no.
going strong.
Wow.
Oh no.
Okay. Information for the next two questions. Pressures of supply and demand act directly on the price of airline tickets. As the seats available on a plane begin to fill, airlines raise their prices. If the seats on a flight do not sell well, an airline may discount tickets, even cancel the flight. Allie Heinrich, a BYU student, wanted to determine if there is a difference in the price of tickets listed 90 days out versus 40 days before the same flight. For her study, she compared the price of one-way flights from London's Heathrow Airport to various destinations in Europe using Travelocity. She recorded the lowest published fares for 90 nonstop midweek flights 90 days in advance, and then found the lowest published price for the same destination again 14 days. The price is given in US dollars. The file is direct notice. Some destination flights were not available. What is the p-value for this test? Answer next 3 decimals.
With this one, we need to put first the 90 days, right?
So this is, yeah, it's, I know that the, if I remember correctly, the hypothesis is that U1 does not equal U2 versus, I mean, U1 equals U2 and U1 does not. So I'm just getting ahead of myself here a little bit thinking. So let's go ahead and do that. So this is 2 test Z-score, correct? 2 sample t-test.
Or is it the paired sample t-test?
Because that is looking if there is a difference in between the price of the ticket thinking it was the pair sample t-test.
Right. So this one is where you got to add that extra column on the spreadsheet and put the difference in.
Yeah,
So this is dependent sample t-test.
correct.
So that's paired, because if you're going to select one, you have to select the other, correct? That's right.
Right.
I'm going back through our review from previous exams as well. So let's see here. So I need this data 90 days first, correct?
Yeah. Let's come up with a p-value of 0.096.
Copy. Variable 1.
0.096.
Yeah,
That's what I got also. And I actually had the 14-day first instead of the 90-day, and it still came up with the same
is that the
p-value.
same? Okay.
I think the only thing that changes, honestly, Carrie, is your confidence interval. It just swaps those around.
Yeah.
You guys should have, and they'll just be inverted. Okay, so I came up with putting that in there 0.9489.
As p-value.
But my no, yeah. What confidence level are we looking for here again?
95.
Okay, I've got that set. That's the wrong one. 0.95, enter. Null hypothesis is 0. Type of test.
Not equal to.
Not equal to. Which changes my p-value to 0.102.
Really?
What did I
Mine
do?
is 0.096 is the one I have.
Me also. Oh, did you? Because there's a few of them that don't have numbers that you got to delete those off of your list.
Really?
I did not delete the empty spots, and still, no, and it's still a 0.096.
So I went through everywhere where there was missing things, and I deleted that whole line.
What's your null hypothesis?
I have 0.
Okay. And confidence level of 0.95?
Right.
What's your...
So do you have a t-score of negative 1.685?
I have a t-score of negative 1.654.
Yeah, that one is different as well. Degrees of freedom 86.
Yeah.
I have the samples for 88, variable 1, 88, variable 2, difference is 87.
I'm sorry, I was looking at something else trying to figure out what I did incorrectly here. So let me... Had to have done something wrong. What did you have for a T statistic again?
Negative 1.685.
Okay, so somehow or another. Let me try this again here. So 90 days. Carrie, you said you need to copy this.
Delete. Yeah.
If I went through and deleted it, because I mean on the question it says notice that there's missing information.
Mm-hmm.
And so
Yeah.
I took that as you just delete that.
And the preparation one was telling us on the next one, I think, to delete the empty cells. It says in 15, it's given us the information.
Yeah, I just reposted without the deleting it, and I have a p-value of 0.105 and a t-score of 1.636. I don't know if that's what you had, Sean, or
Let me double check here real quick. What did you say you came up with?
it was the p-score of 0.105 and a t-score of 1.636.
So what I have is a t-score of negative 1.654 and a p-value of 0.102. So give me just a second to clean this up and see if it makes a difference for me here. So just
Okay.
trying to, so if there's not a comparison, then get rid of them is what you're saying.
That's what I did, yeah.
Did you still have so anytime that there's one that doesn't have one, you eliminate the other?
Yep. Yeah, so I just highlighted the 3 squares and pushed delete, got rid of all 3 of those.
Okay. Did you fill in your gaps so that you whoa, what do we got going on here?
No, I didn't fill them in. So there's still a space there, but I don't think that matters.
No, I just remain with with those pots in there, and yeah, it's giving me the p-value of 0.096. Even though it would delete the amount on those, it's the same because it's not affecting the other one. What happens if we delete the whole row, that's affecting the formulas on the spreadsheet.
Let me just go ahead and try making this data plot a little simpler. Thanks for your patience, guys. I appreciate it.
No worries.
All right, so if I put that in there, let's see what happens. Hello, computer.
Just curious because on the differences column.
Hold on a second. I think I might know what happened here. Just give me just one to clear this up. I'm pretty sure I know what happened. I think I might have residual data, even though I didn't realize it. Let me try that. Clear screen, clear contents. Try this again. Plug it in.
Yeah, I just pulled up again. I just closed the spreadsheet and pulled that one up again, just to have it clear.
Why did that not do that? I don't know. Let me backspace that. I'm going to close this and reopen it and see if that makes a difference, because it's not. I'm even further off than I was before. At least I was 1.6 sometime. Okay. Dependent sample, paired sample t-test.
Right.
Yeah.
I don't know why this is being so weird tonight. Copy. Again. Paste.
So I just shared my screen. That's what I got. But those spots are just left empty.
And I'm looking for not equal to. That's what I'm looking for. So when I do 0.95 confidence interval, not equal to, I end up with a p-value of negative or 0.15. I don't know what I'm doing different than you guys. It doesn't make any sense to me.
Does your data match what I have on my screen?
I'm sorry, what did you say your data was one more time?
Oh, I was just sharing my screen, so it should all the data.
Let me go back to that. I'm not looking at it, so let me have a look. See here. 0.95. 0, not equal to. Oops. I can't see your screen anymore, Carrie. Where'd it go?
Oh, I don't know. Is it?
There it is. There it is. So
your variable 1 and 2 might be switched, but I don't think it matters.
let me see again here real quick. 202, 234. I do. Let me go back and So we should be comparing the 90 days out first, right? Which is 234.
Correct.
So that should be your first one. 234 should be your first column, and 20209 should be your second.
That's the way I have
Yeah.
it. Yes.
So I have it switched on mine, but that just changed the T-score from a negative to a positive.
Yeah.
So why
The p-value is the same.
not? Go back to this here. So go back to your screen again there. Why can I not see carries? There it is. 87, 87, 87. See, I'm 87, 87, and 81. What does that mean?
Your differences, do you have, are you missing some at the bottom of your screen at all for the differences? If you scroll down.
So the only place, go ahead and scroll up real quick.
Yep.
So where they're equal, I have blank spaces, even though there's numbers for both of them, and I don't understand that.
For where? Sorry.
Let me just try this real quick here and see if this makes a difference. Okay, so what's your p-value again?
P-value is 0.096.
Okay, so I just filled in the ones that were, I had some issues over here, and now I have 0.095 or whatever.
Yeah. That's the one.
So that made a difference. T-score of negative 1.684.
Yeah. 685 been rounded.
Okay. All right. Let's see what we're looking. What's the actual answer we're looking for here? P-value.
P-value, which was 0.096.
0.096. So yeah, there was something wrong with my Excel formula. There was data that was cells that were blank. That's where my problem was.
Mm.
Thank you. Thanks for sharing your screen. That helped me figure it out.
Yeah, no problem.
Okay. Number 16 says, based on the results of the test, can you say that there is a difference in the cost of airline tickets purchased 9 days in advance compared with 14 days in advance? Use your level of significance of alpha equal 0.05, and that's no because the p-value was greater than the level of significance.
And the p-value is low. You reject the null. So we failed to reject the null, so that means that they're not equal. Right? Or no? When p is low, you reject. You're right. When p is low, you reject the null. So there was not.
So it's I would go with the first one. It says no because the p-value was greater than the level of significance.
So
because we
it's
got
greater.
Yeah, we got 0.09 and the level of significance is 0.05.
Right. So
Because in this one, the null is that those are equal, and the alternative is that those are not equal.
right. So when it's greater, we fail to reject.
Yep, so it comes to no.
Right. So no, the p-value is greater. Right. Okay. Perfect. All right. So 17, a real estate company wants to evaluate 2 of their home appraisers for consistency and preparation for their annual state certification. It is important that different appraisers be able to give similar estimates for homes and other properties. The company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value. After they receive the estimates for each home, the company subtracts the value given by the first appraiser from the value given by the second appraiser. They create a QQ plot for the differences and see that the points in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied? Explain. So doesn't the straight QQ plot mean that the data is normal?
Mm-hmm. Yes.
So that'd be the third option.
Excuse me.
Yeah, it says, yes, the distribution of mean difference is normal because the data have been determined to be normal. And that's because of QQ plot, it's showing normal distribution.
So one more time on that one there.
So it'd be the third option. Yes, the distribution means difference is normal because the data have been determined to be normal.
Yes, the third one. I mark them down on paper and then can't remember which one it is. All right, so now suppose the company of the previous question wants to use a hypothesis test to determine whether the estimates given by the two appraisers are different. Which of the following would be the most appropriate? So you've got U1 equals, U2 does not equal. So that's what we're looking for is difference. It'd be the first one.
Yes.
Right.
So then number 19 says, suppose you create a 95% confidence interval for a mean and get negative 2.346 and 8.775. You've been told to report this by saying we are 95% confident that the true mean is between negative 0.346 and 8.775. Exactly what does this mean? Let's say it's the second option, which says 95% of all 95% confidence intervals actually contain the true mean. Or do you think it's a different one?
That would be the second one, right?
Yeah. Thinking it's
of all 95% confidence intervals.
right.
Okay.
With number 20, I couldn't remember. How do you calculate number 20?
So I'm having a little bit of a hang up here on our last question.
19?
Yeah. Real quick. Because it's given us the information there of -2 and the 8. Right? So don't we have to have that be part of the answer? Because I mean it's given information.
That could be as well the fourth option.
If you ask me what the definition of a 95% confidence interval means, then I would tell you 95% of all 95% confidence intervals are going to contain the true mean. I would agree with that. But I would say that it's not a chance. We're 95, but it doesn't state it here the way that it should be.
So then the other option that I was looking at was the last one, which says 95% of the sample means are between negative 0.346 and 8.775, which is another way to state the same.
What this means to, I mean, what this question means to me is that we're 95% confident that the true mean is between negative 2.346 and 8.775. That's what that means to me.
Mm-hmm.
Mm-hmm.
What exactly does that mean? So that's what they state. All right, let's just stick with the answer, I guess. I'm sorry I walked you back through that one, but it just... Okay, let's go. So question 20.
Yeah, how do you calculate this one? I couldn't remember. That's one.
Your probability, that's going to be, that was, hold on a second, let me find the formula in my notes. So I don't have that.
I was sticking in my notes, but I couldn't find it.
got for, oh no, that's for standard deviation, so that's not right.
What's that?
I was just looking, I found something for the standard deviation, but that's not going to be right.
Just a second here. Small sample.
Okay, is this where
So
you
n
need to do,
equals which, yeah, that's, I was looking for n equals z star divided by 2 times the margin of error. That's what I was looking for, but it doesn't give us.
yeah,
Go
see,
ahead.
I have the requirements to conclude that p hat follows a normal distribution. That's the np is greater than or equal to 10, or the n times 1 minus p is greater than or equal to 10. Right, that's what we're looking for, to conclude that p hat follows a normal distribution.
Yeah. It says, what is the smallest value of n? So we are looking for n that satisfy the requirements. I remember having these problems in our previous lesson, but I cannot recall of those.
Through this one here again. Check the bar charts. So P hat is a point estimator for the true proportion of P. P hat equals X divided by N. Sampling distribution of P hat has a mean of P and a standard deviation of, so if N times P is greater than or equal to 10 and N times 1 minus P is greater than or equal to 10, you conduct probability calculations. So P equals okay. That has got to be. If P equals 4/5. I know we did some of these. So in order for p hat to be valid, it has to be n times p has to be greater than or equal to 10, right?
Right.
N times 1 minus p has to be greater than or equal to 10. So grab a
Yeah,
piece.
does it have to be both of those? Is that right? It has to be both of those, or is it just one of those?
And yes, it has to be both of them.
Both. Okay.
So with that one being said here, let me see what question around 20 is what it says. So you got to have p 4 divided by 5 is
0.8.
0.8, 0.8. So n times p has to be greater than or equal to 10 and 0.8. And n times 1 minus p has to be greater than or equal to 10. So in order for that to happen, you have to have n times 0.8. Move that to the other side of the equation. 10 divided by 0.8 is 12.5.
I had also.
And then for the other one, n times 1 minus p equals 0.8. Has to be greater than or equal to 10. So you subtract that one, or you divide that one, which is 0.2. So 10 divided by 0.2. And 8 equals 0.2. 10 divided by 0.2 is 50.
I had also.
That's what I get. 50 is your smallest answer.
It has to be both. So it's gonna be the 50. What I ended up with.
Does that make sense, Kevin, when we talked through it? I mean, we did that in...
So first of all, you make a calculation of 4 divided by 5, it's 0.8. And then you had 0.8 multiplied by 10, right?
Right?
Well, it's n. Yeah, n times the 0.8. It has to be greater than or equal to 10. And so to get n by itself, you take 10 divided by the 0.8.
Yeah, so that's 12.5. And then you replace as well the same in the other one, correct?
Mhm.
Okay, gotcha. Thank you. Yeah, I wasn't able to remember it, but thank you.
Like I said, I'm about 3 questions past as far as I'd even had a chance to look at. So,
Yeah,
said-
this is new territory for me too. So,
okay, your little brother has a career batting average of 0.233. You want to determine the probability that he will have a batting average greater than or over 0.250 next season when he will be up to bat 40 times. Are the conditions met so that the sample proportion p hat will be approximately normal? So
Yes, I would go with the second option, which is 40 times 0.250, which is the batting average, which is greater than 10.
this would be the second option.
Yeah, because if we multiplied 40 times 0.25, that's 10 exactly.
I'm sorry, what was that?
The second option, you have 40 times 0.25, that's
Right.
equal to 10.
40 10. Okay. And then the other one, what was your second half of the equation? It's greater than or equal to 10, or it's exactly 10?
Exactly.
Yeah, so greater than or equal to for the answer.
10. What about the other one? 1 minus. Do you not have to do that one as well?
It's not been stated as one of the options, so that is why I did not calculate that one. But if you would like to, we have 1 minus 0.25 times 40. That one is 30.
Well, they're both greater than or equal to 10. Huh? N equals. Okay. All right.
So the next one says a geneticist takes a simple random sample of n equal 140 gamete sex cells from the testis of a dog to determine the proportion which contain the chromosomes for development into a male. Assume the unknown true proportion of a dog gametes that contain the male chromosome is 46%. The geneticist conducts her survey and calculates p-hat equal to 0.512. Which of the following is the most correct interpretation of this statistic? That one. Two.
Cells.
I was thinking the third option, which says 51.2% of all gametes in the dog's testes have the male chromosome. Because p-hat is the calculation out of the total chromosomes.
Mm-hmm.
So what is?
Because from the total sample, 51.2% is the percent having the chromosome.
So you have value minus. We don't have a mean, do we?
We do not. I was just taken as deduction.
I think that isn't the true proportion of dog gametes that contain the male chromosome at 46%. That would be 0.46 versus 0.51. So isn't this going to be calculating a z-score? Does it give us a standard deviation? Or am I overthinking this?
Because the question is, the genetics conducts her survey and calculates p-hat equal to 0.512. It's just asking us how to interpret the p-hat.
Okay.
So by interpreting that one, I'm going with the third option.
Okay, I was overreading. I'm sorry. This is why it takes me almost 4 hours to do my tests.
Yeah.
Okay.
It's better to make sure.
Of all the gametes in the dog's tests, this is going to be in this sample, right?
Yeah, because 51.2, it's the percentage out of the whole sample.
So it's not in all. It's the fourth one, is it not?
Because the definition says takes a simple random sample of n equal 140 gamete sex cells from the testis of a dog to determine the proportion which contain the chromosomes for development into a male. Assume the unknown true proportion of dog gametes that contain the male chromosome is 46%. The geneticist conducts her survey and calculates p-hat equal to 0.512. Which of the following is the most correct interpretation of this statistic? It says the fourth 51.2 of all gametes and the sample have the male chromosome. All gametes in the dog's testes have the male chromosome. Those are very similar, third and fourth.
Because we're dealing with the sample. N equals 140.
I was going with that one because on the first part of it says n equal 140 gamete sex cells from the testis of a dog.
Right.
So
So,
have-
yeah, we're not worried about all of them in the testes. We're worried about in this sample.
Yeah.
So,
Right. Yeah, I think that's right.
I think it's 4.
I agree. I think it is also, Sean.
Okay.
I could be wrong, but I mean, they've given us the N equals 140, so that's our sample size. We don't know what out of all the sperm cells that are in there, we don't know how many of them are male totally.
Right.
So, but of that particular sample, it was 51.2.
Okay.
All right. Last one. Question number 23 now. Researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. In the US, 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the N equals 750 adults over 65 in the study suffer from one or more of the conditions under consideration. Give your answer to 3 decimal.
But that's when I was using the formula which says p hat equal to 0.427 minus 0.45 divided by the standard deviation, but the standard deviation being calculated at the square root of p times 1 minus p, and all of that divided by n.
You lost there. So,
I was taken just to calculate the standard deviation first. It's 0.45, which is p,
0.45 is P, right?
multiplied by 1 minus 0.45. That divided by 750, which is n.
Mm-hmm.
That's 0.00033 and the square root of that. And 0.0182 and a whole bunch of numbers.
Okay.
So with that one, that's the standard deviation. So just to calculate the first portion of the formula, it's 0.427 minus 0.45. That's negative 0.023. And that divided by the standard deviation. And then I came up with a z-score of negative 1.266.
Okay. So,
What was that z-score again? Sorry, negative.
Negative 1.266. And since the p-hat, it's 0.427, which is lower than the mean.
okay,
This. Go ahead.
I'm sorry, but I'm still lost here a little bit here. So, calculate your standard deviation, correct? You did that first, which was 0.018. Am I following you correctly?
Yes.
All right. So then you enter that into your value minus your mean divided by standard deviation, correct?
Correct. And with that, I came up with a z-score. That's
So
negative.
which one was your p-hat?
It's 0.427.
Where does that come from?
Dividing 320 by 750.
I guess I don't remember how to calculate that. P hat is X minus N. X is your observed minus your, is that what we're getting at?
Actual is divided. 320 divided by 750.
Right, so but P hat is X minus N. In this case, 320 is your observed is X that you're looking for less than is what we're trying to figure out. So it's 320 divided by 870 or 750
750, yes.
equals 0.426, correct?
Yep.
P hat, that's your standard deviation here. Sorry, standard deviation. P hat equals 320 divided by 750. 0.426. So round that up to 4. Do we round that here or just leave all those as sixes?
And just put it as negative 1.266 and put that on the applet and came up with a probability of 0.103.
So probability of 0.123, is that what you said?
0.103.
0.103. Okay, and so we're looking at,
Because it's just the left side being shaded because our p hat it's lower than the mean.
okay, so what was your z-score again on that?
Negative 1.266.
Okay.
It's 0.103. Okay.
0.10. That's the probability. 0.103, right? Okay.
Correct. Is that what you're getting as well?
Yes, if I work it through it, I got lost over on standard deviation and remembering the right formula, value minus mean. Yeah. Once I walk.
Again, it's exactly the same.
Okay. All right. Not sure if it's my turn or not, but here we go. Suppose you're testing null hypothesis of P equals 62.62 against does not equal 0.62 for your alternative, and you have calculated the test statistic Z equals 1.334. The area to the right of Z equals 1.334 under the standard normal density curve is 0.91. Which one of the following is a p-value of your hypothesis test? Let me see here. So if you enter a z-score of 1.334,
Correct.
you shade right only, correct?
Just the right side.
0.911. So that would be
The second.
right.
Yep.
For 25, it says, suppose you are Doug Breeder and you want to use a confidence interval to estimate the treatment fertility levels of Hudderbird Cocker Spaniels. It is known that the distribution of fertility levels of Cocker Spaniels is normal. How many measurements must you have in order to be sure the sampling distribution of X is normal?
It is known that the distribution of fertility is normal. So any n should work in this case because it is known that the distribution of the fertility levels of Cocker Spaniels is normal. So your parent populations, so any level of n should do.
Yeah,
Right.
by that line being stated, any n will do. Yep.
Do you guys
All right.
agree with that?
Yes,
I do. Yep.
that's what I chose.
Okay, so question 26. A study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportion of men and women who dislike anchovies are different. A sample of 41 men was taken, and the p-hat estimate for the true proportion of men who dislike anchovies was determined to be 0.67. A sample of 56 women was also taken, and the p-hat estimate for the true proportion of women who dislike anchovies was determined to be 0.84. Are the requirements satisfied to perform this hypothesis test?
Yep, those are met.
And the requirements for that once again is
Let me double check. I am getting on. I just calculated for the first one the n times p-hat. Found it's right. But then by going with the other one and as n times 1 minus p-hat, that one for the first one it's complied. 1 minus p-hat 0.67 times 41, it's 13. But then for the other one is 1 minus 0.84 times 56. Yep, that's 8. So I would say then it's the last one. No, because in at least one case, n times 1 minus p-hat, it's lower than 10.
So it'd be the no.
so on paper, it's because the women's size was too small. So in this one, it's because one of them is less than 8.
3 were complied and 1 was not complied.
So n times p has to be greater than or equal to 10. And n times p has to be, or n times 1 minus p, excuse me. 1 minus p for both groups has to be greater than.
Yeah.
Both. Right. All right.
Okay, with 27, it says a study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between before and after scores. What is the correct alternative hypothesis for this analysis? I would go with the last one, P1 not equal to P2.
Yep, I think that's right.
Because it's not a mean, but it's a value.
Okay. Well, I better plug in my computer before it dies. Give me just a second here. Okay.
Okay.
It's not a mean, it's a value. Just to make sure. Okay. Yep. Because it's an observed, right?
Correct.
It's a value that you observed. We're not actually taking means or sample means.
Correct. Yes.
Okay. Thank you. So Weight Watchers wants to predict how much weight a client would lose if they followed a prescribed exercise program as well as their diet program. Volunteers were randomly divided into 2 groups. One group dieted but didn't exercise, and the other group dieted and followed the exercise program. The exercise group, they used linear regression with percent compliance with the exercise program as the explanatory variable and pounds lost in 3 months with the response variable. One of the clients was told that his residual was 5.5 pounds. What does this mean? residuals were his predicted weight loss pounds higher than it would have been if he didn't exercise. Is that correct?
That's the one that I was thinking. Because it's a comparison in between, but as well as a residual.
I don't remember what residuals were. Oh, I struggled with this one.
Actual weight loss was 5.5 pounds higher than it would have been if he didn't exercise.
Residuals equals y observed minus y predicted.
Yeah, so it's the differential. So which means 5.5 was higher. So it's the difference in between if they would exercise and if they wouldn't. In this case, yeah, the third option is the most accurate one. His actual weight loss was 5.5 pounds higher than it would have been if he didn't exercise.
Residual equals observed minus predicted. So are we? Is it?
Or do you think is the first one? Because those, it's in between those two. It says his predicted weight loss was 5.5 pounds higher than his actual weight loss.
Yeah. So if you're going to take observed minus predicted. So if I predicted you were going to lose 150 pounds and you lost 145.5, 145.5 minus 150 is 4.5. Well, that's a plus. That's a negative number. So
if you're placing it that way, the second option.
Predicted. Yeah. So the predicted was, or predicted minus actual, or was it the actual minus predicted?
Well, it says in my notes residual equals y observed minus y predicted. So
yeah, the observed, that's the one that we got. It's the actual.
Right. So it would be the second option.
Yeah.
So in order for it to be positive, it's got to be a second number, right? His actual weight loss was 5.5 pounds higher than the predicted.
Than him predicted weight loss. Yes, correct.
Okay.
29 for the study in the previous question, the B1 of the regression line was 5 pounds. Interpret the statistic. Question 29.
B1 is slope, right?
Yeah.
B1 estimates slope in regression.
Not the second option, which is an average. The exercise participant lost 5 pounds more than non-exercisers. Or because the first one, it's not down. The average weight loss of all participants was 5 pounds. As percent compliance goes up by 1% on average, 5 pounds are lost in 3 months. Not enough information is given to answer this question.
I would say it's the third one because that's too slow. So if you're looking at it on a graph, the answer would be for every inch you go over 1, you go up 5.
Right, right.
So I mean, so if your compliance goes up by 1%, you're going to go over, or you're going to 5 pounds.
Okay.
Okay, so third option. All right, question 30. When creating a scatter plot, a residuals plot, and a QQ plot, which of the 5 assumptions about linear regression are being checked? Check all that apply.
This is the one we missed last time. So I was thinking on this one, what we are able to identify by the scatter plot, a residuals plot, and a QQ plot, it's that the residuals are normally distributed. There is a linear relationship between X and Y. and I was doubting about the other three options. Because those two for sure. For the cuplet, we know those are normally distributed by the residuals plot. We're able to know that there is a linear relationship in between.
So it shouldn't be the first one, right? The x value is a measure without error. I don't think any of those check that.
So we're looking at residuals are normally distributed, correct? We said that.
Yeah, and the fourth option as well. There is a linear relationship between x and y.
Okay. So mark those two and move forward. Is that our plan? I look back through my notes and I don't see anything else on that. So, I mean, I'm going to have to go back and rewatch the videos again. And
because if we remember on the test we did on Tuesday, we marked those two, and as well the observations are independent, and we missed that question.
Right.
And then we marked them all, and we missed that question.
Yeah. Okay, well then let's stop right there.
That sounds good.
Okay, so then move on to the next one. 31.
You guys, my boss is outside my office door. Give me just a second here. I'll be right back.
Okay.
Okay.
These are long preparation quizzes.
Yes, indeed.
Because those are the wording.
Yeah, I know some of those are really tricky.
Because the calculations are not that hard. It's just procedure. The interpretation, that's what it's killing me.
Yeah.
Because you think it's one thing, and then whenever you do the other, it's a different thing.
Like so many of the things sound similar, but they're off just a little bit.
Yeah. So with this one, the number 31, just to get ready with this one, it's the same airline tickets. It says wanted to predict the price of tickets 14 days before a flight based on the price of the ticket listed 90 days before the same flight.
Yeah, I'll get that to you. All right, I'm back. Thanks.
Welcome.
Okay. Press alignment, the price of tickets. So now we've got bold lettering here, so they want to do something else, huh?
They want us to use linear regression to predict the 14 days tickets.
Okay.
So we need to use the t-test for linear regression, having an explanatory variable, tickets at 90 days prior, and the response variable, which is the one being predicted, 14 days prior on that column.
Okay, so with that being said, one more time, Kevin, which one did you, Excel, which one did you say was primary?
X as 90 days and Y as 14 days.
X is 90 days.
Yeah.
Y is 14 days. With that being said, do I need to remove my spaces again, or we?
I didn't, because it's not making, well, on this one, since we have residuals, I don't know if it's making any difference.
Okay, well, we'll find out.
Let's check if it changed something. No, it does not affect.
We're good?
So the question is asking for the correlation coefficient.
which is R, correct?
Yep.
R is 0.780.
Yes.
That's what I got also.
Then question 32 is just to create a scatter plot. It's the same one which has been given on the spreadsheet, but I was not quite sure because we have an outlier.
Yeah, you got that one way out there.
Yeah. Just not taking in hand the outlier because in reality those are affecting. I was thinking second option, having a linear with a fairly strong positive association
I agree with that.
because it's just one outlier.
Which one was it? Sorry, linear with
The
a fairly
second
strong
option.
positive.
Yeah.
I would say that also based on your R score, your R score.
Because it's strong, it's closest than 1 to than 0.
Yeah, I mean it's not 9. It's fairly strong. So I mean that's a fair
Correct.
answer.
Yep.
33 is asking for the y-intercept.
So the y-intercept, if I remember correctly, is the B1, which is 0.6 or no.
And the intercept is the one above.
115.640. It's B naught.
Yes.
115.640. Let me write that down.
And the slope is the other one.
115.640 and that's y-intercept. This doesn't ask for y-intercept. And slope is 0.627. All right, 115.0 0.627. Okay, so predict price of tickets 14 days before flight based on the 290. 200.
So with this one is the one that we need to have the 115.640 plus the 0.627 times 200, right?
I thought you just put x equals 200 and it predicts it at 240.979. Enter x into the enter 200 into that. Predicted 240.979.
Right, yeah, if you just put that 200 in there, 240.979.
Or are we supposed to do this by?
How much are you using that formula? The
I didn't use the formula. I just put it in the. I'm sorry if you'll repeat the formula. I didn't mean to step over you. What was the formula again that you were talking about?
The one I was using is y hat equal to the intercept plus the slope times x, which is 200.
Right, we did plenty of those. I just write those down. I just plugged in 200 in the area. Where'd my 27 go? I put it somewhere here. I must have left that at home.
Yeah, it varies a little bit. The predicted on the spreadsheet, it's 240.90. Actually, it's 241, right?
Yeah, 241. Because we have to put the 0 because it says to
Yeah, because it says one decimal place. Because if I calculate this on the formula, it's 241.04. So it varies like 5.05.
So what answer are we going to go with then?
I would go with 241.0.
241.
Yeah.
Okay. And so that one, once again, that was y hat. 'Cause I don't have my paper here with
What
me.
is it? Y hat equal to the intercept plus the slope times x.
Okay.
We're ready to go on to the next question. For the next 3 questions, construct a 95% confidence interval for the slope of the regression line obtained when a 90-day before flight ticket prices are used to predict 14 days before flight ticket prices. We want to find the lower bound first.
All right, so 241.
For slope, the lower bound I am getting it's 0.518.
Yep.
The upper
I'm sorry,
0.7.
what's that again, Kevin?
The lower bound, it's the 0.518 for the slope.
0.5.
Yeah, and the upper one 0.735.
Okay, 0.735.
Margin of error, we have 0.735 minus 0.518 divided by 2, 0.109. I'm getting as margin of error 0.109. Is that what you're getting as well?
Just 1 sec.
So 0.735. 0.735 minus 0.518 divided by 2, 0.0, excuse me, 0.1085.
Yeah.
Hold on,
If
sorry,
you,
just a sec.
if we round it to 3 decimal places, will be 0.109.
0.109 minus 1085.
Sorry, what did you guys get again?
We had the upper bound minus the lower one, and then the outcome of that divided by 2.
Doesn't that just find your mean and then you gotta?
Yeah.
And then what were you thinking again, Carrie?
Well, so once you got that, then you just got to subtract that number by the 0.518 to find the standard deviation, don't you? Or the margin of error? Oh,
I thought when we did
sorry.
margin of error, it was upper bound minus lower bound divided by 2.
Yeah. It's because the space in between those two is in the middle we are having the mean. So the mean is
Okay.
the same above and below. So that is why the difference in between those we divided by 2.
Okay. So what did you get for the margin of error then?
0.109.
Okay. Yeah, that's what I came up with also. Doing it that way.
I find it interesting that they don't say round anywhere, but that's in this one, but that's all right. All right.
For the next 4 questions, conduct a hypothesis test to determine if the slope of the true linear regression line is not equal to 0. Choose the correct null and alternative hypothesis for this analysis. That's the second one, right?
H naught B equals 0. H alternative is B1 does not equal 0.
Yeah, it's the second option.
B1, B1.
Yeah.
Okay. Test statistic. We're going back to the same thing we had before, right?
Yeah, because any different information that's provided. So
Test statistic is 11.509, is that correct?
Yes, 11.510. The p-value.
How did you get to? Because I show 11.509.
Right, yeah, so if we're rounded to, I think you were rounded before we needed to.
Because there's nothing behind the 9, so there's no sense in rounding it up.
Well, are you seeing that on the spreadsheet? My test statistic is just 11.510.
Huh? Mine on the spreadsheet says 11.509.
Mine says 509 also.
Did you erase the 200?
Let me see. Hold on a second.
Because the original is 6 on X.
6.
It stays 509.
Still the same?
Uh-huh.
Yeah, mine stays 11.509.
Yeah, so do you want to go with 11.509 then? Okay. 509. Then the p-value is 0.000.
Yeah.
Too small.
P-value is 0. A lot of zeros, right?
Yes,
Yeah.
3 zeros.
Okay.
That brought us to question 42, which is the third option, which says reject the null. There is sufficient evidence to suggest that the slope of the true linear regression line does not equal to 0. We conclude that there is a linear relationship between 14-day ticket prices and 90-day ticket prices.
Reject the null. There is sufficient evidence, correct?
Certainly, yes.
Yep. So third option. Okay, so question 43. In the United States, mothers who live in poverty generally have babies with lower birth weight than those who do not live in poverty. The mean birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. CDC carries out a study to test the effectiveness of a new prenatal care program in reducing the number of low birth weight babies born. For the study, 30 mothers, all of whom live in poverty, participate in the program, and birth weight data is recorded. Which hypothesis test would be most appropriate for this study?
I would say it is the one sample t-test.
It's a sample proportion, right?
Well, it's not asking specifically for a proportion, or is it? For a
It is.
It's not asking.
The mean birth babies. She wants to know. Probably generally babies with low birth weight.
But we're testing the effectiveness of the new prenatal care program.
Yeah.
So yeah, I think one sample t-test is what.
Yeah, I would say the one sample t-test because it's not asking for a percentage.
Mm-hmm.
Okay. I guess once again, I got ahead of myself here and read too much into it because I thought we were dealing with the Okay.
Okay, 44 says engineers had an oil refinery find out how easily gasoline evaporates if measured its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of the vapor pressure of the gasoline made by the refinery is always 0.03 pounds per square inch. Which hypothesis set would be most appropriate for this task? This one. Because the question says they need to determine whether its vapor pressure is high enough. Is it not an independent sample t-test? Because we have gasoline and vapor as well, but what we want to determine is whether its vapor pressure is high enough.
So your hypothesis would be that but that's your standard deviation. That's not your mean.
We have an independent sample.
Yeah, I don't know with this one.
Okay, engineers are well trying to find out how he's guessing.
Because then if not, it's not a paired sample. Could be as well one sample t-test, but we're handling a standard deviation as well. So that is why I was thinking it was the independent sample.
Okay.
Go with that one, and we can.
Try that one and see how it goes. So independent sample t-test.
What'd you say? Independent sample?
Yeah, I can be wrong, but that's the closest one I can identify.
I'm just trying to figure out, if I can't remember here, why the standard deviation is part of the equation here. That's fine. Let's just move forward. These word problems always mess me up anyway, so. My goodness, I thought we were done. We're not done.
No, there are 47.
All right, so 45, an attorney wants to know whether the percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would be most appropriate in this situation?
I would say the test of one proportion, because he's looking for one percentage of only one group.
That's what I was thinking also.
Me too. Marriage counselor conducted a study of couples, categorizing each of the couples as communicative or non-communicative, among other things. The counselor wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative couples whose marriage ended in separation or divorce. which hypothesis test be most appropriate? I'm going to go down to test of two proportion.
Correct.
That is what I was thinking.
The last one says a business marketing firm specializes in radio advertising. They hope to show there is a linear relationship, and by that one we said it's a linear regression. Let's submit it and let's see. It's been 2 hours already, though.
Yeah.
Oh, yeah, we really got into this one, didn't we?
Yeah. All right. Let's see how we did.
Fine. Oh, we missed number 3. That was too soon to find question we missed. We missed as well number 4. 5. Oh gosh.
Oh no.
7. This will drive me crazy. And after 7 until number 18. 21. Oh. 24. 27. Number 30, we got 0.8 out of 1. We missed 39 as well. Gosh, it's up there a lot. We missed 44. And that's it. We missed a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Okay, so I'm sorry, I'm going back through them once again here.
Yeah, me too.
Let's go back and review.
I didn't mark down exactly which ones all you said, Kevin. I was looking at a couple other things here, trying to make sure I had answers written down on my paper as well.
No
So
worries.
you
Just write those down as well.
3 and 4. Okay. 3, 4. Just 5 as well, huh? Great. Okay. 4. Seven. So if we got 2 out of, we almost got all those, so we're just missing. I'm missing the info there. Okay. 39. Wrong. 44. Which was what's 39? 39 was wrong. Guess I need to figure out exactly what question that is. 39. I marked 39 is wrong, and it's the numbers don't add up on the paper. 39 is H naught. So 39 on here is actually 36, correct, on the paper?
I think so. Yes.
Right. 40, value of the test statistic. T, this is actually 40. 41. Okay, that's correct. 42. And we get 243. 143. That was correct. And sample t-test. 44 is the engineers at the oil refinery. That is not an independent T sample. 34, 45 was a test of one proportion. We were correct on that one. 46 was a marriage counselor. We were correct on that one. And 47 was actually linear regression. Correct. All right. Are you guys ready for round 2, or are we going to call it a night?
We can repeat the ones we missed.
All right.
Yeah.
Go back and start over.
Go through. Yeah, maybe just go through and just do the answers, not read the whole question, except for the ones we missed.
Okay. Start quiz again here if this thing will open up. All right. I'm going to go back to in question 3, this being an observational study because they had no control over the price.
Sorry. Okay, so then with number 3. Since it was not the one we selected, head over which sampling method they used. Since indeed,
I still think it's an experiment and not an observational study.
yeah, I still think it's an experiment. So then it's not the sampling method, then it will be that the students had control over which
Well, the
cereal.
reason that I think it's an observational study is because they're going to observe. They're not truly making an experiment. They're not administering anything to the cereal. All they're doing is they've selected it, but they're not seeing if cough syrup A is better than cough syrup B.
Yeah.
Hmm.
The question says to get a sample of cold cereal prices. So if what they wanted to say sample of cold cereal prices,
See, they're not applying anything to them. I mean, all they're doing is
Right.
they've taken two items and they want to go see what the prices are. They have no control over either one of those variables. Doesn't matter whether you start
Right.
Cheerios or Lucky Charms. They're just observing it.
thinking it that
Yeah,
way,
I
so
get what you're saying.
to deal with prices. Yeah.
Yeah, they're just going and making observations. They're not observing whether their variable, their cough syrup fixes the problem, or whether their flu shot has a difference
Right.
between placebo and. So I mean, it's an observer. To me, this is an observational study.
So then
Yeah,
I'll
that makes sense. I get what you're saying. So I agree that we should try option B, or the second one.
yeah, because students had no control over the price of the individual cereals.
Right.
With 4, it says for a Math 221 project, one group of students studied the ages of students on the BYU Idaho campus. They collected data from a random sample of n equal 100. The sample mean 21.2 and the sample standard deviation was 2.61. An excerpt of the data is given below. The group notices an error in the data. The age of one of the males, id equal 3, was entered incorrectly. He's actually 21 years old. When the error is corrected, what happened to the sample median?
So the median is the one that's like directly in the center of the highest and the lowest, isn't it?
Yes, it's not the mean, which is the average.
Right. So I think we were thinking of the mean would increase if they changed that.
Yeah,
But
so
I think
then
the
it
median,
will stay the same.
yeah, or I mean, we don't know what because maybe the 21 would be the new median. I don't think we would know without the full data set.
Yeah, as well, that can be. So in this case, it can be that it's not possible to determine this without the full data set to calculate the actual median to determine if it will stay the same.
So you think it's not possible to calculate?
It can be that one, or the median will stay the same.
So give me just a second here. One of you guys want to read those numbers off real quick? Just the ones that they show us. I know we don't have the full data set. Let's just run a small experiment here.
It's 21,
Yeah.
18, 21, 20, and 25.
Go a little slower. 21 what?
We have 21, 18, 21, 20, and 25. So the median in this one, it's 21.
So it's 12. What was the one without because where's the 12?
The 12 is after 18.
Okay.
Yeah, so that one should be 21. Which in
Yeah.
that sample, the median would stay the same, but we don't know what.
What it's in the other. Within this experiment, the median will remain as 21. But as Carrie said, we have
I mean,
94.
ID number 5 was like 29, and that would change the median.
So when I changed that and put it in a spreadsheet and ran the median calculation, your median goes from 20 to 21 in that case.
Which it increased, right?
Yep, it increased, which was our wrong
And
answer.
we know, yeah, that wasn't the right answer. So I don't think it's possible if we don't have all the other numbers.
Yeah, we don't have all the data.
No, for sure.
Okay. All right.
Number
There you go.
5. That's the next one we missed. The time to complete a standardized exam at the BYU Idaho Testing Center is approximately normal, with a mean of 7 minutes and a standard deviation of 10 minutes. Using the 68, 95, 97.7 rule, approximately what percentage of students will complete the exam? I think,
So with this, so it says with the 68, 95, 99, 7 rule that
yeah,
68% will be within 1 standard deviation, and then 95 would be within 2 standard deviations, and then 99.7 would be within 3, right?
Right.
yes.
So if we have 70 is our mean, and then we have a standard deviation of 10. So 1 would put us at 60. 2 standard deviations would put us at the 50. So 95% should be within that range, right?
What percentage of students will complete the exam in under 50 minutes? If we follow the formula we did, our answer was 0.023. So let's check. Time to complete a standardized exam on the BYU Idaho Testing Center is approximately normal. What do you mean of 70 minutes and a standard deviation of 10 minutes? Using approximately what percentage of students will complete the exam under 50 minutes? I would say 68%. Because using the formula, 50 minus 70 divided by 10, the z-score of 2, place it on the applet. Says -2. The min is 70. And they are looking something in a short amount of time. 50 minutes will be the lowest percent, 68. But it says as well on the answer, give your answer accurate to 1 decimal place.
2.3.
That can be 2.3. Because we give it as decimal and not as a percent.
Mm-hmm. Then it would be
2.3 then, yeah. And we placed 3 decimal places. And it's asking us this percentage. Yeah, I suppose it will be 2.3.
To 1 decimal place. Let's try that.
That's a 2.3.
Yeah. So the number 6 was correct.
That was 146.8, right?
Yeah. So the number 7, we had that one incorrect. Because we cannot be sure until we examine the data. So I think then it's the skewed right.
Yeah, that's what I would think it'd have to be.
Because if we did so with the other ones having the normally distributed population, even though the sample was not that large, I think this example falls into the same theory.
Yep.
Okay. Number 8, got that one right, 2.236.
2.236, right?
Yeah.
2.236. Make sure you enter the right numbers and don't do what I did last time.
9 was correct as well, 0.991.
I'm sorry, 0.981?
991.
0.991.
Yeah.
I heard you wrong. I had 991 written down, and then I'm like, uh-oh.
Yeah. And number 10 was the probability of a type 1 error.
Probability of a type 1 error.
11. That's when it's an area of opportunity for us. We were not able to get this one right after 3 attempts. We got 0.8 on this one. Oh, no,
So
sorry.
isn't this one we got right?
No, this one is fine. I was thinking of the other
Yeah.
one. This one is the
This one
third
was
and fifth option.
Approximately 95 of all 95s, and we are. Oops.
Yeah.
All
Third
right.
and fifth option.
The third and fifth. Approximately 95.
12 is the second option. The distribution. Okay.
Did I mark this down wrong?
Number 12 or 11?
11. I've got 95% of all 95% confidence intervals that could computed of the population for an adult female will contain the true mean height. And what was the second one?
The fifth option. We are 95% confident that the true mean height of adult females in the United States is somewhere in our confidence interval.
That's not what I wrote down on paper that we put for our answer.
Oh, that's what I had also for those two options.
We are 95% confident that the true mean height of adult females in the United States is somewhere in our confidence interval.
That's the second one. Yes.
That's what you guys put down. Okay, I marked. I must have just marked wrong here without reading. So I just want to make sure I'm doing it right.
Yep. So the third and the fifth option. So
Third and that's probably what I heard, and that's why I marked, because the fifth one doesn't match up here on paper.
yeah.
Okay.
Okay.
For number 12 is the second option. Yes, the distribution of sample mean is normal because the data are normal.
The data are normal.
Number 13 is 0.019.
Okay.
Number 14 is the second option, dependent sampling. Number 15 is 0.096. Number 16 is no, because the p-value was greater than the level of significance.
Which was the first option.
Yeah. 17 is the third option. Yes, the distribution of mean differences is normal because the data have been determined to be normal. And we missed 18.
18.
It says, now suppose the company of the previous question wants to use a hypothesis test to determine whether the estimates given by the two appraisers are different.
It's C. I messed that up, guys. It's the differences. I completely spaced that out when I threw it in there. You're looking at the mean of your difference is equal to 0 or it's not.
Okay, so C
And
on
is
that
the
one.
third
The third option.
Yeah.
third option. Okay, number 19 is the second option.
95 of all 95.
Yeah. 20
Okay.
is 50.
20
0.
equals 50.
We missed 21. I don't know how in the world. Because your little brother has a career weighted average of 2. The weighted average is 233. You want to determine the probability that we'll have about an average of over 2.250 next season when there will be up estimates of the sample proportion.
So you go P hat. Let's see here. So you got P is 233. That's as observed. P hat minus P. So 250.
We selected the second option last time and it was incorrect.
Uh-huh.
So then I was thinking it was 250 times 40 because that's the batting average they were wanting to have and achieve. Having that one incorrect can be the third or fourth option because it says no, p hat can only be normal if the sample data are normally distributed. And as well, no, because 40 times 0.233, it's less than 10. So the conditions are not satisfied.
Yeah, I'm leaning
I would
towards
go
that
with,
last
Yeah.
option.
I would say that.
yeah, I would go with the last option.
Okay, sounds good.
Yeah. So ready to move on?
No. Almost. Writing down on paper, so it's the last one. There we go. I'm in the computer. I'm good. Don't overthink
Okay.
it. Geneticist. The game it's in the sample, so that is the final one.
Correct.
The last one.
So then for next one.
23. What were we looking for here? I got something. P value, is that what we're after?
And which one?
We're on question 23, right?
For question 22. For question 22 is the last option, 51%.
What's that? Yeah, it's the last one. Question 23.
Okay, 23, it's 0.103. For question 24, we missed 24. It says suppose you're testing H naught P equal to 0.62 against P not equal to 0.62, and you have calculated the test statistic to be negative 1.334. The area to the right of Z score equal to 0.334 under the standard normal density curve is 0.091. Which one of the following is the p-value of your hypothesis test?
Let's see here. We didn't even put this in the normal probability apple, did we?
Yeah.
So what was the Z score again?
1.334.
1.334. When I put that in the probability applet, it tells me that the p-value is 0.9089.
Okay, so then it's 0.09. I'm sorry, 0.909.
Yes.
Last one.
Okay.
25 is any n will do.
So
26.
Hold on a second here. So I almost closed that out. That wouldn't have been good. Any n will do.
Yeah. 26 is last option. No, because in at least one case, n times 1 minus p hat is less than 10. For number 27, we missed 27. It says a study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between before and after scores. What is the correct alternative hypothesis for this analysis? And what we chose before.
Once again, I was looking at the wrong thing. It's differences. So you're looking at your hypothesis. The difference equals 0. The difference between the two does not equal 0. So it should be.
So option 2.
The second option. Then number 28 as the second option, his actual weight loss was 5.5 pounds higher than his predicted weight loss.
His predicted weight loss was 5.5 higher than his actual.
Yeah. 29 as the third option, as percent compliance goes up by 1%.
So for 28, sorry, that was the second option we chose, right? Actual
Yeah.
weight was,
Correct.
sorry.
So I just observed was predicted. So his observed, his actuals has to be higher than
Yeah.
predicted.
The actual is higher than predicted.
It has to be higher in order for it to be a positive number, right?
Yes.
Mm-hmm.
Actual weight loss higher than predicted weight loss. Okay.
Okay, for 29 as the third option. For question 30 as the one that we are still missing something.
Okay, so residuals are normally distributed. There's a linear relationship between X and Y.
I don't know.
We just need one. Do any of those check the variance of the error term is constant for all values of X?
I don't know. I don't know.
That's one. I don't know, because the X values are measured without error. Nope. Variance of the error term is constant for all values of X. It could be that one, or the observations are independent.
I thought we chose observations are independent already.
Yeah. So then would you like to go with the variance of the error term is constant for all values of X?
Sure.
Let's try it. See what
Let's try
happens.
that.
Sure.
Or 31, it's 0.780.
0.78.
Right. For number 32, a second option, linear with a fairly strong positive association. 33 is 15, I'm sorry, it's 115.640. For number 34 is 0.627. For 35 is 241.0.
Sorry.
For 35, it's 241.0. Then for 36, that one is 0.518.
Hold on a second. My numbers are off here again. I'm getting screwed up. So 36 is, what did you say 36 was?
36 is 0.518.
Okay, so
37 is 0.735.
8. 0.735.
38 is the margin of error for 0.109. And we missed 39.
0.109.
Let's see, we chose the second option for this one.
Yeah. Let's choose the correct null and alternative hypothesis for this analysis. We are having a 95% confidence interval for the slope of the regression line obtained when 90 days before flight ticket prices are used to predict 14 days before flight ticket prices.
Capital B1 equals 0. Capital B1 does not equal 0.
That one, you think?
That's what it says in the notes. I don't know how we missed it.
Okay, so the last option.
Yeah. So then 40 is 11.509.
I thought we put 11.510. Or no, we did change it. You're right.
Yeah, 509. Yeah.
2.509.
Yeah. Then for
You're right.
41 is 0.000. Number 41. Then number 42 is the third option. Reject the null. There is sufficient evidence. 43 is a one sample t-test. 44, we missed that it's not an independent sample t-test. It has a standard deviation. At an oil refinery, find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its pressure is high enough to the standard deviation. The vapor pressure of the gasoline made
This
by
is a one sample Z test because our standard deviation is known.
That's the first one.
I went back and just our standard. Yep.
You're right.
That makes sense.
I just went back to the spreadsheet, the flow chart sheet. Looked that up.
Thank you. Then for 45, it was a test of one proportion. 46 was test of two proportions.
Hold on a second. I'm gonna get these cut up. So 45 is one sample Z test. Correct?
Yeah.
46 marriage counselors paired two sample.
What'd you get for 45?
One proportion.
Isn't that what the one we just talked about? 45 is the
Test of one proportion.
hold on a second. 44 is the engineers. That's the one sample Z test.
Yeah, 44 was the Z
45
test.
is one proportion. Where'd that go?
Mhm.
Yeah.
Where'd that go? Test of one proportion. Thank you for catching that, Carrie.
Yeah.
46 is the marriage counselor. That's a paired two sample t-test.
No, that is test of two proportions.
Test of two proportion. Paired two. How did I get that? I wrote that down wrong. Two proportions.
And the last one is the linear regression.
Say 47 is linear regression. Save.
Let's say 3 is correct, 4 is correct. You still miss number 5. Number 7, correct. Let's check number 18. Number 18 is correct now. 21 is correct. 24. We missed 24 as well. 27 is correct. 30. Oh, we got it. 30 is correct. It was the variance of the error term is constant for all values of x. 39 is correct. And 44 is correct. So we missed 2 only. 5 and 24.
Well, that's a lot better than first time.
Yeah. We tried.
Yes, we did.
Okay.
Good job, gentlemen. So, Kevin, are you gonna submit? Is that what you said? You're gonna submit the PowerPoint?
Yeah, that's due on Saturday. So just
Okay.
if you have pictures besides the one I have, we'll be fine if you can send those. I
Okay.
just
Yeah,
work
I
on
will
that
try
one.
to send some.
Okay, so that's what I am missing, just some more information than the one we have at this time, just to make it more detailed and short. So I'll send you a draft before I submit it, so you can take a look.
Huh. So evidently, I'm somehow or another I'm frozen, but you can still hear me, so that's good.
Yeah.
Yeah, I didn't realize it until now.
I haven't held that position for hours. So
No.
so what my thoughts were was I would put together a slide in PowerPoint. I'll try to get a picture attached to that.
Okay,
And then just send you that and you can incorporate it into your PowerPoint. Is that
that will be okay. Yeah, that will be great.
okay?
Okay, so then I think we have one last meeting next week.
I think you're correct.
Yeah, it is.
One more.
Yep. And just want to tell both of you thank you. It's been a good semester. You've helped me out a lot. I appreciate it.
Oh yeah, absolutely. Both of you too.
Yes, as well. So hope you have a good night.
Likewise. We'll talk to you on Tuesday.
Okay.
See you.
See you guys.
Good night.